Hello YouTube viewers, welcome to my channel S2T, and in today's video we're gonna talk about Future Friday. So what is the topic of today's show? Well, it's Xenobots, and I'm reasonably sure you need no introduction, but let's still dive right into it. So what the heck is this Xenobot? And I'm reasonably sure you have seen this everywhere. Every website, every newspaper is covering this. So why it is such a big thing? Well, first it's a small thing and it's a miniature. So it is under 1 millimeter. However, you can see it with your naked eye if you put it against very bright light and very contrasty situation. It is seeable. It's not nanotechnology. It's miniature, and it is man-made. Now there have been attempts of growing living things, and we have been successful with that. However, this time it's not growing things together, it's like splicing things together. Okay, let's take cells from here, let's take cells from here, and abracadabra. So that's the reality of it. Now the reason why it is classified as biological machine, well, technically everything is biological machine, is that because we define what it's supposed to do. Because every cell is generally of two category: either it's a specific cell, let's say your heart cell, your skin cell, it's a specific cell, or a living cell where it's like, it's doing everything required for life, be single cell life forms. So in this scenario, every cell has a defined purpose. We are creating these puppies which are like, dude, you're gonna do this, you are built for this. So it's like, butter passing robot kind of Rick and Morty scenario here. So that's why we are calling it quote unquote machine, quote unquote drone, quote unquote robots and all that jazz, because we are telling it like, dude, you are built for this, you're gonna do this. And now why the heck the name is Xenobot is there? The sole reason the name is Xenobot is simply because it is made out of frogs. Now frog have billions of species and all that jazz, but one of the specific frog used for this experiment is known as African frog generally, and in evolutionary chart it is specified as Xenopus frog. I have no idea why. So but that is why, like Xenopus, they took and then they made a Xenobot. So that's the reality of it. It's a miniature bot which is human made, not human grown, human made, and it's a machine that we can program. It's like, bro, you gotta do this, and they will do it, and it is made from Xeno frogs. So what's the science behind it? Science is simply, think of this way: we took multiple types of cell, because if you take, as I specified earlier, like there are types of cell which are like built for one thing. One cell is built for like only contracting and expanding. Another cell is built for like, retaining as much moisture as possible, acting as a barrier, like your skin cell. So each cell has a different type. So here we took two specific types of cell. We are like, okay, we're gonna take heart cell, we're gonna take skin cell, and we combined them together. Now this is very critical aspect, because you have to understand cell inherently have an ability to bond with each other, and that's why you actually stand, like that's why your skin is like, your skin, skin have this inherent behavior pattern to them. We started to exploit them. It's like, hey, cell wants to be bond together, let's bond two dissimilar cell, and it stuck together. Now behavior aspect of it, that is the core reason, the whole fact, the reason why we are excited about this. It's just not like, growing ear on a frog's back. We have done that, don't look it up. But again, it's like, okay, we're gonna build this, and we're gonna build it for this specific purpose. Now purpose, again, it's a miniature, so what can we truly expect? It was like, move in a straight line, move in round and round, delivery a drug or basically food or nutrition to another cells or things of that nature. So this small puppy inherently in principle is acting like a nanobot, as close to nanobot as we're gonna get. But again, if it were truly nanobot, we wouldn't be able to see it. So that's the science behind it. Now let's understand the step-by-step process of it. Again, for more details, please do research on your own, but this should give you some idea of what the hell went into making this. Now we gathered stem cell. Now if you are familiar with stem cells, you have to understand stem cells come in two categories: one differentiated, one undifferentiated. Think of stem cell as a blank CDs. If you put music into them, it becomes MP3 CDs. If you put basically video in them, they become video discs. So stem cells are like that. You put data into that, and they become that specific cell. So before that data has integration has happened, you will call it undifferentiated. Basically, it can be anything. Once that happened, once the data has been encoded in them, they start to behave basically like, I am becoming a skin cell, I am becoming a heart cell. So we took two specific type of cells. Now the reason skin cell was used is because anything that moves in this world requires a thing to counter push against. Basically, action equals reaction. You need something to push against. Even snake internally has a structure that allows it to push against itself and move in the world. So you need something as a, like, quote unquote backbone, quote unquote skeleton. So skin is doing that. Now heart cell, you got your skeleton, you need muscle to move it. So which cell is going to do that? Heart cells. Why? Because heart cells are small and they fluctuate like a madman. So that is acting as a quote unquote engine. Basically, you got your skeleton, you got your muscle, and the blueprint, how the heck you going to connect these two? Because yeah, it is true that cells can be bonded together, but how the heck you going to make sure that they actually bond together and they can actually move rather than just flatter around like crazy? Is that computer gave a rough estimations. It's like, okay, do this or this should happen, and they built it in a lab. And if you see this basically microsurgery, it is specified, these are very small, these are like less than a millimeter. However, the people who are dealing with embryo based biology, they were like, yeah, this is normal for them. So it's not a quote unquote new achievement that we can splice cells. We have been doing that for human embryos for quite a long time. So these are the steps. You take cells, you differentiate two of them, you combine them in exact blueprint that computer provided, and you do it in a lab. Now then comes the interesting part. Then, because so far everything is normal, so far this is like what people do in a biological lab. However, this time what they did, something interesting. Now again, this may be happening in hundreds of other labs parallelly. There may be labs that are doing this covertly, but they are announcing what they are doing. So basically they are taking the data. Computer gave up them a data like, do this, do 2 plus 2, tell me the result, and you got the result is 5. So you fed that result into the computer. Now computer did something interesting. It is a supercomputer. It's not a baby computer, it's a supercomputer. It ran evolutionary algorithm. Now because it's getting calibrated data from the lab result itself, like reality happened like this. So computer's simulation became progressively much more refined, and they ran through billions of combination. Again, it's a supercomputer, so it's virtualized like crazy. So they ran through billions of computational data and evolutionary algorithm to come up with an actual cell design, basically bot design that will work. So they took that bot design, they made it in a lab, fed that data again into the computer to refine the computer's algorithm, and they did it again and again and again. So they reached to a point, the time where they are publishing this result is like, they're gonna tell the computer, bro, give me a bot design which allows us to capture a small basically volume of material, be it a medicine, be it a cancer treatment, and just carry it from point A to point B. The computer came up with that design. That's why you will see multiple graphs shown there, because this green cells will be generally your skin cell, red will be your heart cell. Now computer is become so good at this point in time that it can actually define like, okay, if you build something like this, it will keep going round and round. You built it in lab, it will keep going round and round. That is the amazing aspect of it. That is the reason why they needed a supercomputer, because a human could not do this. Simply you could not run billions of simulation. Computer can. And if you can keep providing data to the computer, it's like, hey, I think your computer is like, basically drifting, basically its results are not accurate. The reverse correction, that is actual real life based, computer became awesome. They are like, yeah, this computer can actually reach that point where it's like, yeah, do this, you will have this output. So that's the feedback aspect of it. So what was the result? The result is the what you saw in the news, in all the articles, the biobots basically. It is a working drone. Now, quote unquote drone, because when we can control its behavior, but it's no longer like we have a remote control there where like, go from point A to point B. It's like, it's gonna do its own thing. Basically, all it's gonna do is move from point A to point B if it has nutrition. And if it gets injured, it's gonna heal itself together. Now, however, there are many behavior aspects that is very well tuned. We wanted it to be tuned. We came up from a supercomputer and we fine-tuned it. However, something interesting also happened. It ended up showing a lot of unknown behavior. Now you have to understand this. This is one of the tricky aspects of evolution, is that you have cells. Okay, cells make sense. So how the heck you go from cell to consciousness? That's a very big jump. It's like, it's like you have two cells, they are behaving like 2 plus 2 equals 4, and randomly you have like 20 plus 20 equals 50. It's like, what the hell happened? So that is the unknown part that's happening here. These cells are actually demonstrating things that are like bit confusing. It's like, does not make sense, but it's happening. It's absolutely real. It's like, some of the cells just simply went back. It's like, what? But it happened. Like, it's a real thing, and they are learning about that right now. So what we can expect in the future? Now you have to understand this. I have to specify this again and again. This is very early stage. This is like just beginning. Now again, researchers, and they have to exaggerate it, because if they don't, they will not get the funding. So I can understand their plight. However, I really don't understand why the heck news media over exaggerates it so much. But again, it's a very early stage, because we have to figure out every single unknown behavior that is presenting itself before we can it's gonna go into your heart and it's gonna clean your basically blood vessels. Yeah, no, just no. Right now, no. And not but to mention, it's not even that small. Like 1 millimeter is may sound small. It's not that small. So it's not nanotechnology, and it's much bigger than your single blood cell. So it is very early stage. Like this is like just we starting to survive. Like we are dipping our toes right now. Now, how long before it can be used against human? 20 years. Now, if you're like, oh, that's very long. Well, think of it this way. Einstein comes up with a mathematics known as laser. Engineers comes along and they built a actual laser, demonstrated like, okay, we can actually do something that is provided in the paper. Then somebody else comes along and that does something else, like making barcode, making CDs, making DVDs. How long do you think that process took? It takes time. It's by default inherent nature of science itself. It will take time before it becomes mass production. Very long time. Now, because of our modern one, because of the data bandwidth that we have, it will be much quicker. Instead of like 60 years, I can easily see it in 20 years. However, it still will take time. And not to mention, because we have a lot of things like ethics. Now, ethics is very complicated because simply because the people who are dying, and you are like, hey, we have this cuckoo experiment that may save you. That person will simply say, dude, take me up because I am dying anyway. It's like no one is gonna be like, oh, no, I'm not gonna take this risk. I'm like, dude, I'm dying. But again, ethics companies will be always like, dude, you cannot do this. Like, you cannot do risky behaviors, or you cannot do anything that has a higher probability of damaging the individual. But the individual that is dying will be saying like, what the hell, why you're wasting my time? So there is a lot of hoo-ha here. That is not very clear cut. Now, other aspect, we are making life forms and all that jazz. Like, is it ethical and all that? First, if you are eating chicken, no, you do not get to claim about that. Simply because we literally devour creatures for our food. Like, it's not that we cannot exist without them. We can live without it. But we literally create creatures. We eat creatures, and we do that. That's normal. That's life. So claiming that we are creating new life form, it's ethical or not, yeah, that's meaningless. We're gonna do it anyway, and even if you shut down it, somebody else will do it. So that's a gibberish. Then we have to understand this aspect. This is the first time we are doing this. This is the first time this whole loop has been run. It has to be run multiple times, and it has to be run with multiple species also, like frog cells. Okay, what happens if you do basically lambs, or what happens when you use snake, or whatever have me. And it has to be replicated in multiple universities, multiple labs. So lot of looping has to be done time and time again. And the more time we loop it, the more time we understand it, the more time we'll understand how the heck those uncontrollable behaviors are happening. Now, there is one critical aspect that you have to understand. That is the quote unquote puzzle of evolutionary biology. As this point in time, as in 2020, we humans know evolutionary biology is absolute, because we make medicine based on that. We make vaccines based on it, and it works. So it's true enough. Problem is, we at this point in time, we do not know how the heck that emergent behavior happens. And we have run computer codes where they're like, okay, do A plus B equals C, and we did that, like, but randomly started to create random things. Now it has happened again and again in computer programming, that people have actually started to look seriously, like there is something inherent to this universe itself, where you are like 2 plus 2 equals 5 happens, that we classify as emergent behavior. Think of it in a very simple way. Something you have experienced in your life is that water, right? Water is simple. Water has hydrogen, it has oxygen, it has a defined parameter. You freeze it up. Now it's supposed to happen, nothing fancy about it. But how the heck ice crystals are formed? Now, if one design of ice crystal happens, no problem. It's like, okay, this is the most maximum surface area, minimum stress, and all that jazz. Okay, awesome. But how the heck all these are happening? And these are just few designs. There are millions of designs. So how the heck that is happening? How the heck, the simple behavior of hydrogen with oxygen with temperature is creating this millions of outcomes? It's like, how the heck 2 plus 2 equals 5 here? And this is what we classify as emergent behavior, where you like everything in your science will tell you like, okay, do this, you will get that, and you will get it. It's like these are solid. So if you simplify your mathematics is like water will go from liquid state to solid state, and these are solid state. So if science is true, it's not breaking science, but something else is happening. So same with our brain. It's like, what happens if you cut one part out? Okay, you lost that part, but you still retained your consciousness. But what happens if you do that with a dog? Let's say a dog had a stroke or something like that. Is it still a dog? Yes, it is. So how the heck that is happening? We need all of those things to make a consciousness, but somehow it can survive removing one aspect of it. Or again, why the heck our supercomputer does not randomly become sentient, even though it has like all those components? It has optical recognition, it has speech recognition, like whatever we want to put into it. How the heck that is happening? So that emergent property is the next hurdle. Basically, we know science is there, we know something is happening, we know it's absolute. Heck, even our computer simulations are showing us before we can even expect it. Like there are people who built ant simulation where ant was like, go left, go right, go left, go right, and randomly it will start to create tank threads. It's like every time that happened, this was quite amazing. Like this was happening in the simulation. So there is something in the inherent nature of this universe where this emergent properties happen, and same we are seeing this with biobot also. So understanding that is amazing. That's like pushing it to next level. Think of this way: our biology right now is on a Newtonian level. It's like we know gravity, we got this, but we do not know what gravity is. So we are waiting for some Einstein where it's like, bro, gravity is space-time curvature. That's what's happening here. So what the heck is gravity? You needed Einstein to explain that. Same will soon, hopefully, more and more researchers are pouring their heart and soul into this. Somebody will figure out like this is what we are talking about, because it has happened in computer, it has happened in real life when we are building life creatures, and it happens all around us. So that is the amazing aspect of it. That is why this research is much bigger than most people can anticipate. Not for those, oh, it's gonna cure your heart issues and tumor and all that. That will happen way far back. So don't pay your attention into those aspects, but this is still amazing work. So this was my presentation on basically biobots. I hope you liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I'd urge you to press dislike, press it twice to show me your extra disappointment, and please leave a comment because I try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.